My dear friends, today I'm going to explain what is the inertial force, and second one, which is non-inertial. It is also called fictitious force or the pseudo force. Fictitious, what it is. Normally the students confuse what it is actually. Okay, first of all I'm coming, what is the inertial force? Let me take an example. I'm having a coordinate system, x, y, z. Okay. Now, there are the two masses, m1 and m2. This is the origin. The distance of, or you can say, the position vector of m1 from the origin is r1 vector and directed outward, meaning increasing outward in direction. Here the mass m2 having position vector r2. Now there will be a force between the two, that is the gravitational force, and this force will be mutual, mean m2 will exert a force, or m2 will apply a force on m1, m1 will apply a force on m2. So let I write the force on m1 due to m2, on m1 due to m2, mean m2 will attract m1 along this direction. So what is this direction? You apply the triangle law. This vector, same order, it is opposite order. Okay, so this plus this becomes equals to this. That means this vector is this minus this. That it is r2 vector minus r1 vector. So f12 constant, m1, m2, and magnitude, distance, this is a vector. I am writing magnitude and square. This force is the mutual force interaction. It is the interaction. One particle is interacting on the second. This is, which is the interaction. This is a real force. This is actually a real force because the particle masses, they're interacting. And real force is called the inertial force. Okay? Remember always, because of the, mutual influence or the interactions. When they're mutually interacting, it is a real. Like I'm interacting with you. It is a real. Now I'm coming, what is a non-inertial frame? What is a non-inertial frame? Non-inertial, a frame of reference in which an isolated or free particle experience a force. Whenever there is a force, okay, if there is a force in a frame, there is a force in a space. Frame mean what? What is the meaning of the frame? Frame mean a space, x, y, z, with time. That is called a frame. Frame in a space and with time. Okay. If in a space there is a force, okay, that is non-inertial. If there is a space where there is no force, that is inertial. If there is a space and there is a force, that means non-inertial. And inertial law. What are the inertial law? Like Newton's first law, second law, third law, Newton's law, they are inertial law. Does not holds good. They are not applicable, inertial law. In an accelerated frame, mean in a space where there is acceleration, there is a force, and there will be no inertial law. Okay? And what are the examples? Rotating frame. Because whenever a particle is rotating, it has uniformly accelerated motion. Rotation means changing direction continuously. If the direction changes, velocity changes. Velocity changes mean acceleration. So that is, if there is acceleration, rotating frame, it is non-inertial. Now I am coming what is a fictitious force in an accelerated frame. So very, very important. Try to understand very carefully. I will try to explain, but even then, if you have any problem, don't hesitate then. Okay, this is one frame, green. It is the frame which is at rest, not moving. This is origin. This is the frame S. There is a second frame, the red one, that x dash, y dash, z dash. It is accelerating. Okay, this frame is in acceleration with respect to S frame. This green is S, red is S dash, S is at rest, S dash, it is in motion, but that motion is accelerated motion. And initially, O dash was coinciding with O at t equals to 0 time. 0 time was that time when this origin and this origin was coinciding. Then it starts, its journey. Then after time t, it reaches here. Now what is this distance from here to here? Which is capital R vector. So capital R vector is, the equation S equals to ut plus half at square. Okay, and there is no initial velocity. Distance is half at square. So this R vector is equals to half at square. Very simple. Okay, now the next thing which is again important, that here is a particle. Okay, this particle, when you observe this particle from here, maybe particle is moving, no problem, but at any instant the particle is here. Okay, and what is position vector from S frame? R vector. And when you observe the same particle from S dash, the position vector will be R dash. Particle observed from S, position vector R. Same particle when observed from red frame, position vector is R dash. Now what is the relation between these three? Triangle law. This vector and this vector, they are same order. This is in opposite order. So it becomes R vector plus R dash vector. This is dash vector. This one is equals to this vector. Okay. Now substituting, the value of R vector here. Okay. And this R vector becomes R dash vector, and instead of capital R, I am writing half at square. Now differentiating both sides, d by dt. Okay, when we are differentiating, then it is clear this particle is moving. This particle is moving because R is changing with time. So when I am differentiating, means the particle is moving. So once you differentiate, t square becomes 2t, 2 and 2 cancels. It is 80 then. Okay. Now again differentiating. When you again differentiating, means this is a differentiation of velocity. And when velocity changes with time, that becomes acceleration. Now that means this particle is in acceleration with respect to frame S, as well as with respect to frame S dash. But the problem is, what is acceleration with respect to S? What is acceleration with respect to S dash? Because this frame is itself, it is in acceleration. This red frame is also accelerating. Its acceleration is A. Now we have to find because I am saying particle is also in acceleration with respect to S and with respect to S dash. So what is the relation between the three accelerations? One, the frame itself accelerating, particle accelerating with respect to S, particle accelerating with respect to S dash. And that relation is, we are coming to that. When you are differentiating it, it becomes d2r dt square, and this is all dt upon dt square, that becomes 1. Now what is d2r over dt square? This is acceleration with respect to frame S. This is dash. This is acceleration with respect to dash frame. This is the acceleration of the frame itself. Okay, if the frame is not accelerating, if a equal to 0, means frame is not accelerating, then there will not be any difference between the particle you observe in S or S dash. The acceleration will be the same. If the frame is not accelerating, then no difference. But because it is accelerating, then these two acceleration will be different. Now the particle is the same. It is accelerating, but its acceleration will be different for S and different for S dash, because this frame itself is accelerating. Okay, so after this equation, then I'm multiplying, m both sides. I'm multiplying, that become force. This is a force experienced by the particle with respect to S frame, force experienced by the particle with respect to S dash frame, and force experienced by the frame itself. Okay. Now try to understand this equation. Now suppose point P is isolated in frame S. Okay, suppose point P is isolated in frame S. Isolated in frame S means the particle is at rest with respect to S, mean no velocity, no acceleration, mean this AS equals to 0. There is no AS. If there is no AS, what becomes? It becomes AS. There is no AS, there is no FS. There is no FS. And that becomes this plus this equals to 0. Mean F vector is equals to minus Fs dash vector. Okay, what it implies? This particle is at rest with respect to this frame. Okay, but if you observe same particle with respect to red frame, then particle is at rest. This frame is accelerating. This frame is accelerating. From accelerating space, you are from this frame is accelerating. This particle is at rest for this space, for space S. But if you observe the same particle for the red space, red frame which is accelerating, then you will see this particle having a force, and that force is Fs dash, and Fs dash is equals to minus F vector. Okay, mean the particle is experiencing a force, even it is not moving, with respect to S dash frame, and this force is opposite to the the force which is acting on this space. That means the particle experiences a force even it is not moving with respect to S frame, but if it is observed from the frame S dash, it is experiencing a force. This is not a real force. This force is originating because of rotating frame. Because of accelerating frame. As a frame is accelerating, and due to accelerating frame, and there is a force in this space because of the acceleration, but when this particle is absorbed, then we found this particle experiences a force. This is a fictitious force, not the real one. Not the real one. It is originating as because of the acceleration of this frame. So this is also called the pseudo force. Pseudo force. So this is the basic concepts. Means sometimes the force appears, which is not real, because of some space which is in acceleration. That's the reason. Okay. Thank you very much. This is all about this article. If you have any doubt, no problem. Do not hesitate. Write me. Do not hesitate. Write me in my comments box. I will definitely answer. But this is my request. Please share my videos to your friends. Okay? Thank you.